Okay, so a really nice lowest common multiple question to start off the paper. 3 marks available here. Buses to Ashby leave a bus station every 24 minutes, and the buses to Barford leave the same bus station every 20 minutes. They both leave at 7:30. When will they next leave the bus station at the same time? So 2 ways of doing this, and I'm going to do both just to show you. With relatively small numbers, it's actually not too difficult to go 20, 40, 60, 80, 100, 120, 140, and then to go 24, 48, 72. And don't forget, this is a calculator paper, so if you wanted to do this with a calculator just to make sure you got it right, 96 and then 120. Wonderful. So we've reached a number that is on both lists. Let's circle 120 to make it really clear that we've identified that as the lowest common multiple. And then 120 minutes is 2 hours. So if 7:30 is the time they're leaving, at the minute, we're going to add on 2 hours, and we'll know that 9:30 a.m. is the next time that they're leaving the same. You must put a.m., okay? It's not 9:30 p.m., it's 9:30 a.m. That's one way of doing it. Now, these numbers were quite small, so that was quite efficient. But if the numbers were much bigger, it becomes harder. So if you wanted the lowest common multiple of 2 numbers, you do the prime factorization. So 2 and 12, 2 and 6, 2 and 3. So 24 is 2 times 2 times 2 times 3. And 20 is 2 times 10, 2 times 5. So 2 times 2 times 5. You then do the Venn diagram for 20 and for 24 and put what you can in the middle. So we can put a 2 and a 2 in the middle because they both have a 2 and a 2. This one's got a 5 left over, and this one's got a 2 and a 3 left over. If you wanted the highest common factor, you times together just the numbers in the middle, 2 times 2. But if you want the lowest common multiple, you do 5 times 2 times 2 times 2 times 3. 5 times 2 is 10, times 2 is 20, times 2 is 40, times 3 is 120. So this is another method of getting this number rather than listing. Kim, Laura and Molly share £385. The ratio of the amount of money Kim gets to the amount of money Molly gets is 2 to 5. Kim gets £105 less than Molly. Now, £105 is the difference between what they get. So if, and I think on Hegarty they use boxes actually, so if we do boxes like this, so Kim gets 2 piles and Molly gets 5 piles. So this is Kim here, these 2, and this is Molly here, these 5. Now, if they gave us the total amount of money, we would divide it into these 7 piles. But because they've said that Kim gets £105 less, we know that the difference between what they get must be 105. And if I do 105 divided by 3, because those are the extra boxes that Molly gets, we get 35. Yes, 35. 35, 35, 35, 35, 35, 35. So every box must be the same. Okay, so Kim gets 35, and 35 is 70. And Molly gets 1, 2, 3, 4, 5. So she gets 35 times 5, 175. And then we're asked about Laura. Now it's Kim, Laura and Molly. Kim and Molly we've sorted. We just need to work out how much Laura gets now. Now the 385 is the total amount of money. So add together 175, add 70. 245. And then 385, take away 245 is 140. So that must be what Laura gets. And then we need to do that as a percentage. So as a percentage, we would do 140 out of 385 times by 100. Always what you want out of the total times by 100. And I'm just going to type that in my calculator using the fraction button. So 140 out of 385 and then times it by 100 is 36.36 recurring percent. And you were allowed anything from 36.3 to 36.4, and they actually accepted 36% for that. I think I'd put 36.4 or 36.36 recurring percent. Don't round it too much. The price of all tickets, rail tickets, increased by 5%. The price of a rail ticket from London to Ipswich increased by £2.30. Work out the price of the ticket before the increase. Now, the most important thing to recognise here is that this is a reverse percentages question. You're not being given 100%, okay? Our first job is to work out what percentage we are being given. And hopefully we can recognise that this is the increase. So this is the 5%. Now, your first mark is just for linking that. So if you were to write £2.30 equals 5%, that is going to get you a mark, okay? To recognise that that is not 100%, it's 5%. Now, if that's 5%, the easiest way to get to 100%, so the price of the ticket before the increase, would be to times it by 20. We've got 5% and we want 100%. So let's do £2.30 times by 20, which is £46. And that's it. A garden is in the shape of a rectangle ABCD and a semicircle. AD is the diameter of the semicircle. Carol is going to cover the garden with fertiliser. A box of fertiliser costs £4.99. She's been told that one box of fertiliser will cover 12 metres squared of garden. Work out the cost of buying enough fertiliser to cover the garden completely. Okay, so this is broken down. We get 1 mark to find the area of the circle of a semicircle. We get 1 mark to find the area of the whole garden. 1 mark to find the number of boxes, and 1 mark to find out the cost, and 1 mark for our correct answer. So this is a 5-mark question, okay? Really nice 5-mark question. So first thing I'm going to do is work out the rectangle. So 8.4 times 5.6, base times height for a rectangle, and that is 47.04. And make sure you write down what you're typing in your calculator. And I just like to put that on the relevant area as well to make my answer really clear. And then we're going to do the area of the semicircle. Now, remember that the area of a whole circle is pi times the radius squared, but we're going to have to half it because we only want half of a circle. The radius is 4.2 because it's 8.4 all the way across. We can see that from here. So this bit would be 4.2. So in my calculator, I'm going to do pi times 4.2 squared, and I'm going to half it. So pi, remember, is shift and then the times 10 button at the bottom, times 4.2 squared, divided by 2, because it's a semicircle, not a whole circle. And you get that answer in terms of pi, but we just want it as a decimal. So I'm going to write down this answer, 27.708. Notice I've written it all down. Now, the reason for that is I don't really want to round anything until I get to the very end of my question. Now I need to add those two together. So take that answer that I just got. That's the easiest way to make sure that you're being accurate is to, which way? That way, there you go. Take the answer that you've just got and add it to 47.04. And that is 74.7488472. So the total area, 74.7488472. And we know that every box covers 12. So we're going to divide that by 12. And that's 6.22. Now we can't walk into B&Q and say, oh, we'll have 6.2290706 boxes, please. So we're going to have to buy 7 boxes. We're going to have to buy 7 boxes. 6 isn't enough. And I know that this rounds down, but we can't do that. We need more than 6 boxes. So we need 7 boxes. And it's going to be 7 boxes. And each one costs £4.99. And that is £34.93. And that's 5 marks there. Okay. So far, we've covered on this paper 3 marks on question 1, 4 marks on question 2, 7, 8, 9, 10, 11, 12, 13. We're at 14 marks, okay? 14 marks on this paper would have been enough to get you a grade 4. So, well, just about, okay? So that's kind of the amount of questions that you need to do to get a grade 4. But we need to do that on every paper. And so it's just about getting as many marks as you can. The bottom bit says, Carol finds out that 1 box of fertiliser will cover more than 12 metres squared of garden. Explain how this might affect the number of boxes she needs to buy. Well, if it covers more area, she might need to buy fewer boxes. Less boxes. If the area is more, then we don't need as many boxes. Now, before I answer this question, it's a good idea to just have a good idea of what things look like on a graph. So let's look at these. This one here is just x cubed, okay? Y equals x cubed, or something like that, okay? It just goes to 0 and carries on going like this. This one is also a cubic, but it's likely to have more terms, something like y equals x cubed, maybe 2x squared, I don't know, 6x minus 8 or whatever, okay? It really curves. This one's a cubic. So both of these start at the bottom, have a wiggle, and go up to the top. So they're both cubics, and we would expect them to have something like x cubed, okay? With C, it's linear. It's a straight line. So we'd expect this one to be of the form y equals mx plus c. No powers, because powers are what makes it wiggle. This one is an exponential function. So we can see that as x gets bigger, y is just going to grow exponentially. And you might have heard of that a lot at the minute with coronavirus. The number of cases are growing exponentially. So this one is y equals something like 2 to the power of x, and we'll look at that in a minute. This one's y to the power of y equals 2 to the power of minus x, or something like that, maybe 3 to the power of minus x or something like that. Can you see that it's getting smaller and smaller and smaller rather than this one getting bigger and bigger and bigger and bigger? So this one is coming down. This one's a quadratic, so something x squaredy, and yeah, that's about it. So x squared, I mean, it's not going to be x squared, it might be x squared minus 4 or something like that, but it's a quadratic. The highest power is going to be squared. The cubics, they wiggle. The exponential graphs, they grow. The only one they've not done here, which I think they probably could have done, is this one, which would be something like y equals 1 over x. It's a reciprocal graph. It looks a bit like a fraction. You get a bit up here and you get a bit down here, and that's when x is on the denominator. So for this, I is going to be d, and II is going to be a. It's not going to be f because this is just x cubed. It's just very simple, whereas this one has a bit more to it. Tom grows tomatoes. The box plot below shows the distribution of the weights of 15 of Tom's tomatoes. Work out the interquartile range. Now, you've got a few things that you need to know here. This is the lowest value. That's the least weight of tomato. Then we've got the lower quartile, the median, the upper quartile, and the highest value, so the heaviest tomato in this case. Now, you will find 25% of your data is here. 25% of your data is here, which makes sense because the median is the middle. 25% of the data is here, and 25% of the data is here. The lower quartile is where 25% of the data comes up to, the median's in the middle, and the upper quartile is where, so 25% of the data is above, and that's where the value is there. The range would be the highest value take away the lowest value. The interquartile range is going to be your upper quartile take away your lower quartile. Now, the upper quartile, if we look at this, we are going up in 1. So 160 to 170 is 10 squares, always worth checking. So we've got 166 as the upper quartile, take away 158 as the lower quartile, and that would be an answer of 8 for that one. For the bottom bit, Jack also grows tomatoes. Here are the weights in grams of 15 of Jack's tomatoes. On the grid, draw a box plot. Now, they've been really kind here. They've already put them in order for us. The first thing you would need to do if they weren't in order is put them in order. Now, we can tell that the lowest value there is 153 and the highest value is 186. So I'm going to go ahead and put those on. Those are my whiskers, if you like, of a box and whisker plot. 153 is there. Okay, so they're going to be my highest and lowest values. I then need to work out the median. Now, if there are 15 pieces of data, we add 1 and half it, and that's going to be the position of the middle. So add 1 is 16, and half it is 8. So it's going to be the 8th piece of data. The other way to do it, obviously, is to do this, but it takes a little bit longer, and it's just easier to add 1 and half it. So 1, 2, 3, 4, 5, 6, 7, 8. So that's my median. Now, we need to look at how many pieces of data are below the median, 1, 2, 3, 4, 5, 6, 7, and go in the middle of that. So it's going to be here, 164, that's my lower quartile. Ignore the circle on the end, that's just the lowest. And then above that, again, we've got 7, so 175 is going to be my upper quartile. It's halfway between the middle and the top. If you have two numbers in the middle, then the median's in the middle and you could go all of these numbers, but because there's a value in the middle, we don't use it and we just go what's with above and below. So then I've got 164 here, and I've got the median of 170, and I've got the upper quartile of 175. Oh, terrible drawing. And use a ruler. Don't do as I do. Okay, and that's your box plot. So then you want to compare the distribution of the weights of Tom's tomatoes with the distribution of the weights of Jack's tomatoes. Now, when you're asked to compare two box plots, normally we talk about two things. We talk about the average and we talk about the spread. Okay, so we're going to say on average, Jack's tomatoes were heavier because they have a median of 170 compared to 162. Really good to state the values and really good to say which one's higher. And then you want to say that if we look at Jack's interquartile range, Jack's interquartile range goes from 164 up to 175. So Jack's interquartile range is actually 11. So if we are comparing that interquartile range, we would say that Tom's data is more consistent because he has a smaller interquartile range of 8 compared to Jack's being 11. Okay, show the equation x cubed add 5x minus 4 equals 0 has a solution between 0 and 1. So to show that it has a solution between 0 and 1, we want to say, well, what happens when x is 0 and what happens when x is 1? So let's try 0 first. When x is 0, we get 0 cubed, add 5 lots of 0 minus 4, and that equals minus 4. So if I put f of 0, that's quite helpful there. And then if I do f of 1, if I change x to be 1, I get 1 cubed, add 5 lots of 1 minus 4, which is 1, add 5 is 6, take away 4 is 2. Now, if the y-coordinate was negative when x was 0, and then the y-coordinate was positive 2 when it was 1, what's happened is from x equals 0 to x equals 1, if you look at this graph, we've gone through the x-axis. So here it was minus 4 and here it was 2. So it must have crossed the x-axis between those two values, and therefore there must have been a solution. Solutions are where it crosses the x-axis, or roots of the equation. So there must have been a solution as it's crossed the x-axis. There we go. Show that the equation x cubed add 5x minus 4 equals 0 can be arranged to give x equals 4 over x squared add 5. What have they done here? So first thing they've done is add 4 to both sides. So x cubed add 5x equals 4. And then we can see they've divided by x squared add 5. Now we're only going to get x squared add 5 by factorising this and taking x out. So x squared add 5 equals 4, and we're then going to divide by this bracket. So they've factorised this, so factorise, and then we're going to divide by the bracket. So x equals 4 over x squared add 5. Okay, and that's it. We've got what they've got. That's another 2 marks. Okay, now this looks horrendous, but I promise it's really nice and straightforward. All it means for iteration, if you're not sure, please look up iteration on Hegarty. It's a really good one to do. Is this is the value that we're going to start with, x0. So this is not a power. This is a subscript, not a superscript. So the first x is 0. And then this formula says, to get the next x, we're going to do 4 over the current x squared add 5. So xn is the value of x you currently have. And by doing the formula, we get to the next n, xn add 1. So we're going to use this to find an estimate for the solution. Now, I'm going to use my calculator for this. Let's start not using calculator, I'll show you. So to get the next x, x1, because we've got x0 at the minute, we're going to do 4 over 0 squared, add 5. Okay, so we're taking the current 0, current x, squared it and add 5. And that's 4 over 5, which is 0.8. So that's x1. We're now going to use our x1. So to get to x2, we're going to do 4 over 0.8 squared, add 5. And here's where the calculator is going to come in handy, because I don't particularly want to be doing that without one. So I'm going to type in 4 over 0.8 squared, add 5. And that gets me 0.7092198, blah, 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 blah. Now, I'm going to make my life a little bit easier, a bit of a trick here. Go back to your, and let's put the answer in here. And then when we hit enter, see, we've got the next one. So x3 is 0.726877, blah, blah, blah. And then if you hit enter again, it's going to take this answer and put it in there. So then x4, 0.72354, you see it's getting closer and closer to being the same answer. And if I just keep pressing it, I would write down a few. How many did the mark scheme say you wanted to do? So the mark scheme said 0.709. No, what have I done wrong? Oh, twice. Ignore me. If you carried on going, obviously it's going to get closer and closer and closer to the answer. And you can see now I'm hitting equals and it's not changing. But it only wanted you to do it twice. Sorry, that's my fault. I should have read the question. So there we go. 0.709. That was nice and easy. Apologies, I made that more difficult than it was. Pot A and pot B are mathematically similar. Now, whenever you see those words, you want to be writing linear scale factor, you want to be writing area scale factor, and you want to be writing volume scale factor. Now, these scale factors are different. If the lines are 2 times bigger, the area will be 4 times bigger, because it's 2 times 2, and the volume will be 8 times bigger, okay? So we need to remember that mathematically similar means scale factors, and the scale factors are different for lines, areas, and volumes. The area of this, of the base of pot B, so the area of this is 160, and we want to get to the area of pot A, and that's going to involve us using the area scale factor. However, look at what you have on both. They've given us a height on both, and a height is a line. So I'm going to do big divided by small, 10 divided by 8, and that's going to be my scale factor, 5 over 4. Don't know why I'm using a calculator, 1.25. So that's my linear scale factor, 1.25. That means the lines are 1.25 times bigger. And if I wanted to get from the width on this to the width of this, we'd divide by 1.25 or times by 1.25, depending what way we were going. Now, the area scale factor, an area is 2D. So it needs to be 1.25 times bigger in one direction and 1.25 times bigger in the other direction. And that means that the scale factor is 1.25 squared, which is 1.5625. If you were asked for the volume scale factor, or if you were talking about volume, you'd need to do 1.25 cubed. We don't need this for this question, but it's good to work it out. 1.953125. So you can see that the lines are this much bigger, the area is this much bigger, and the volume would be this much bigger. We now want to go from this area to this area. And because we're going between areas, we want to use our area scale factor. So I'm going to take 160 and divide it by the area scale factor, which is 1.5625. 160 divided by 1.5625. You can't use the linear scale factor because that's not how much bigger the area is, it's how much bigger the lines are. And we're dividing because we're going from big to small, and that's 102.4. The diagram shows a solid metal cylinder. The cylinder has base radius 3x and height of h. You can see that here. The metal cylinder is melted, so we're going to get the volume of it by melting it. All the metal is then used to make 270 spheres. We have the volume of a sphere here. Each sphere has a radius of a half x. Find an expression in its simplest form for h in terms of x, okay? Now, this is really quite a challenging question, and it's hard to know where to start. But because they've talked about melting it down, it makes me think that we're going to need the volume, okay? It makes me think we're going to need the volume. So let's start with this. Let's start by working out the volume of this. Now, the volume of a cylinder is pi r squared times by the height. It's the area of the circle times by the height. So that's going to be pi 3x squared. Now, don't forget, you can't write 3x squared because that wouldn't be squaring the 3 as well. We need to do 3x all squared times by h. Okay. And that's going to be 9x squared pi h. And that's the volume of our cylinder. And that's going to be equal to 270 spheres that have a radius of a half x. So 270 times this, 4/3 pi r cubed, but we know that the radius is a half x. Okay, really difficult. So we know that the volume of our cylinder is equal to 270 times this sphere, 4/3 pi, the radius cubed. Now when we cube half, we're going to cube the top and cube the bottom. So this is going to become 9x squared pi h equals 270 times 4/3 pi 1/8x cubed. And we can go ahead and sort this out, okay? So let's do this bit first. Let's do 4/3 of 270. We can divide by the bottom times by the top, so you should get 360. 270 divided by 3 is 90, and 90 times 4 is 360. So 360, and we're going to divide both sides by pi as well. Let's get rid of those. Both sides have pi. Let's divide them. 360 times by an 8th x cubed, and this side we've got 9x squared h. Okay, now let's divide both sides by 9 because we can. You might have done this in a slightly different order. You might have done an 1/8 of 360 next, to be fair. Which is, yeah, let's do that. Let's do that. That is 45. So 45x cubed is 9x squared h. Lots of different ways you can do this. Now let's divide by 9. So x squared h equals 5x cubed. And then let's divide by x squared. So h equals 5x. I've divided this side by x squared. And I've divided this side by x squared. And that's it. We've now got an expression in its simplest form for h in terms of x. That's quite a difficult question. It's hard to know where to start. But definitely try and get yourself a mark by working out the volume of something. Okay, it's a really good place. Okay, question 19 might look really scary, but actually this is going to be a bit of SOHCAHTOA here. We've got right-angled triangles. Let me highlight this here. Okay, hang on. CD is perpendicular to both CA and CB. So CD, that's this side here, is perpendicular, so at right angles to CA and CB. So we've got those right angles drawn on, and they've given us all the angles and they've drawn them on the pyramid there for us. Calculate the size of the angle between the line AD, which is this one here, and the plane ABC, which is the floor there. So ABC, yeah, the floor. So we want this angle here. We want this angle here. That's going to be X. We'll write X there. Now at the minute I don't have enough information to work that out, but what I do have is a right-angled triangle here. I have a right-angled triangle here, and I can see that that is 20, 34 here, and we don't know any of the other sides. But let's try and work out this one. This is in the triangle that we want, so that's going to be helpful. So let's try and work that out. Labelling your sides, we've got the hypotenuse, the opposite, and the adjacent. And we want to know the opposite, and we have the adjacent, so we're going to use TOA. If you want to know the opposite, cover that up and do the sum that's left behind. So it's going to be tan 34 times by 20. Tan 34 times by 20. So this side here is 13.49017034. I'm just going to write it all because I like to keep things really accurate until we've got it all together at the end. Okay, now let's have a look at seeing if we can find this side, BD. We can get that by using Pythagoras because we know now that this side is 13.49017034. So we can square that and add it to 20 squared. And that's 581.98. But we're going to square root our answer. Always we square root with Pythagoras. So let's do 13.49 squared, add 20 squared, and then square root the answer, and that equals 24.12. So we've now got that one, 24.12435, so on. Okay, we've then got 45 degrees here, which is actually on this face, and we've got 60 degrees here, which is on this face. What we're looking for is the angle that this line forms with the floor here. So it would be really helpful if we had more information in this triangle here. So if we can find AD, that's going to help us out a lot. So let's find AD. Now AD, we're looking at this face here, ABD. AD. B, and we know that this is 60 degrees. We've just worked out that this is 24.12435, and we know that this is 45 degrees. I also then know that this is 75 degrees, because I know that angles in a triangle add up to 180. I've got 60 and I've got 45 on that face. So this one's going to be 75 degrees. It's not X, it's this one, so it's on the face, 75 degrees. And we're going to use the sine rule here. We've got a pair, and then we've got an angle, so I can work out this one here. So remember, if you want a side, which is going to be this one here, shouldn't really call them all X, should I? But hopefully you know what I mean. If you've want a side, you put the sides on the top. So A over sine A equals B over sine B. So we're going to do X over sine 60 equals 24.12435 over sine 75. Remember, you must use the pairs, so 45 is irrelevant here. And then we times by sine 60. So 24.12435 over sine 75 times by sine 60 is 21.6293. Up there. And now we've got enough information to work out this angle, because we've got two sides and we want an angle in a right angle triangle. It's going to be SOHCAHTOA again, but we've got the hypotenuse here and we've got the opposite. We've got the hypotenuse and the opposite, we're going to do sine to the minus 1. Opposite divided by hypotenuse. Oh, so shift sign. Opposite on the top, 13.49 over 21.6293. And that gives us 38.586. So I should have written that in, shouldn't I? 13 point over 21 point blah, blah, blah equals 38.586. And so I'm going to put one decimal place, 38.6 as my answer.